Welcome to qnawire.
Here we have a rod AB that's 4 inches long, and it's going to rotate with an angular velocity given of 6 radians per second. And we want to find the velocity vectors for points A and G. So A is on the left side of the rod, G is in the center of the rod. If the center of zero velocity for the spar is at point C1, C2, and C3, where each of those points are 3 inches away from point B. C1 is to the left, C2 is to the right, and C3 is down. So if we're at C1, our velocity vectors for VA will be up and VG will be down here. So this one will be a little bit simple for us to figure out because we know that the velocities, so VA will just be omega times the distance between C1 and A. And that's just 1 inch away. So this will times 6 radians per second. So that'll just be 6 inches per second. And we'll get the same thing for G, because G is also 1 inch away. So we get 6 inches per second again. So fairly simple in that case. The next case will be at C2. So now we will have a velocity of G that is up, but slightly smaller than it is for B, which will be further up. And I wrote those velocities in blue this time. So now the two velocities will be a little bit different. VA will be omega times C2A. And C2A will now be 7 inches because it's this 3 inches on the right plus the entire length of the bar, which is 4 inches. So this gives us a total, sorry, not 7 inches per second, but 42 inches per second, because that should be 6 times 7. So 42 inches per second. We do the same thing for VG, but we know that VG is in the middle of this bar, so it's only 2 inches away from B. So the entire length, C2G, should only be 5 inches. And 5 times 6 gives us 30 inches per second. And both of those velocities will be straight up, of course. And then the next thing we want to do is look at the slightly more complicated case where we're rotating about point C. And I'm going to draw these velocities in black to try to differentiate them. But if we're rotating about point C3, then we'll have the velocities moving down this way. We'll just need to find what these lengths are. So lengths C3G and C3A. Luckily, this is fairly simple with the Pythagorean theorem. We know we have 3 inches up. Over to G, we only have 2 inches going between B and G, and over to A, we have 4 inches. So we can use the Pythagorean theorem to find these distances real quick, and I'm just going to put that straight into our velocity formulas. So we have VA equals omega times C3A, which will just be the square root of 3 inches squared plus 4 inches squared, which is just a 3, 4, 5 triangle, so that's just 5, and we get VA is 30 inches per second. Then we have VB, sorry, not VB, but VG equals omega times the square root of 3 inches squared plus only 2 inches squared this time, so this will be a smaller number, and we get about 21.6 inches per second.